Hello and welcome to my video, lesson 7.5, modeling logarithmic regressions. Alright, so here we have a table of values, and it says the height of a specific tree over time is given by the table below. Give the logarithmic expression for the above table. So it really should ideally be telling you in the question if it's a logarithmic expression. Otherwise, it's a little bit hard to tell. And so I'm not going to expect you to know that off the top of your head. But let's plug in that data. So we would get a table of values that looks like this. And then what you would do to get the logarithmic expression is you're going to do regression analysis, right? So you're going to click Stat, go over to Calc. You're going to go down to number 9. Okay, so you can press 9 or Enter once you're down here. Okay, and then you're going to go to Store, and you can click vars, which is variables. You're going to go to y-vars. You're going to click function. You're going to click y1, and then you're going to go to calculate. So this is going to get that data, which this is our parent function here. Just keep in mind that this is ln x, as it says in the calculator, ln x. And if you don't remember, ln x is, like let's say it equals 1. Yeah, let's go with 1. What that tells you is that it's base e exponent 1 equals x. All right, so the ln is base e. When we use log, it usually means base 10. Okay. So anyways, it's in this form, so if we click y equals, you can see all of that written down in this form exactly. So number plus number ln x, and then we can graph it, and what you want to do is click zoom 9, and it should look something like this. If it doesn't have that, then you have to click second function stat plot, make sure that's on, but it should look something like this. So that's amazing. We have ourselves a nice graph. If we look back at this to find our logarithmic expression, we just write y equals 2.06, we'll leave it there, plus 7.69, let's go with 70, and then ln x. Okay, so I know I'm rounding, but that's what we're doing. Okay, so at what height will the tree be at year 10? So if, oh no, I did it backwards. I wanted to ask the other question. I wanted to ask, which year will the tree be 20 feet tall? Okay, so I'm asking a kind of a different question on purpose because then these two have kind of two different ways of doing it. So in this question, we have to, if we're looking for the y value of 20, we're going to put in a y value of 20. We're going to graph it. We don't have enough room, so we're going to make this a little bit bigger. Whoops. Make that 25. 25. Oh, we need a bigger x value, so let's go with 15. There you go. Second function, calc, intersect. Now you're going to go try to find the intersect point. It's right about there. Enter, enter, enter. And so, hey, look at that. I guessed pretty well. What year will it be at 20 feet tall? Well, it'll be at this point in time. This many years. However, because we're looking at which year, it'll be the 10th year. Right? So partway through the 10th year, it will reach that point. All right. So hopefully that gives you some idea. If you can, try this next question out before I do it. Okay, all I'm going to do is I'm going to plug in the table of values here. So What I'm going to do here to plug in the table of values is I'm going to plug it in as if the years were going up by 1. Okay, it just makes it a little bit easier to work with. Because the gaps are the same every year is 10, 10, 10, 10, I'm just doing 1 instead, and so we can multiply our answers by 10 to get the correct answer. But anyways, we now have 1 to 12, and then I'm going to just put in the data points as given. So, oops. All right, if you haven't yet paused it, please do and see if you can get the rest of the way to the answer. Okay, I'm going to continue on and try to solve it. So I go to Calc, I go down to number 9, which is logarithmic expressions, regression, sorry. Down here I go to variables, y variables, function, function 1, calculate. So what this is doing is it's storing those 2 data points into my calculator as y1. What I'm doing here is I'm putting in 42.5 as a 5.3, let's go with 5.3, plus 13.86 ln x. So yes, I'm rounding these. Then I'm going to go to this, and I'm just going to delete my previous value. I'm going to press zoom 9, that's zoom stat. Okay, and it's going to do something like this. I'm just going to change this so that it kind of makes sense. And yeah, let's see if I can just make this a 5, just so it's a round number. Let's go with 15. Okay, that way we can see into the future a little bit. Okay, so we have some data here. I just changed my window functions to make it a little bit more pretty to look at. So it is now 2020, right? Well, it's actually 2021 while I'm recording this. But let's go with what if the trend continued, what would the life expectancy be? Okay, so what you're going to do is say if it's another year, right? So if we went to the next data point, what would it be? So I click second function, and here where it says graph, it also says table. So I'm going to press there, and I'm going to go ahead and go to the next data point, the one I did not plug in, which is 13. So this data point right here is 78.07. That doesn't seem right, but it is because our graph is not exactly fitting with our data. It is roughly right. Okay, I know it's not a perfect logarithmic regression question, but if it were, then it would be perfect. All right, so it looks like it's going down, but it's following a trend of going up. And it would keep going up after this. Okay, so hopefully this video helps you guys understand modeling logarithmic expressions a little bit better. And good luck, everyone.